Infrastructure as code. Infrastructure as code is a modern approach to IT infrastructure management that involves automating the provisioning and management of computing resources through machine-readable definition files or scripts. Rather than the manual hardware configuration or interactive configuration tools, it is a key practice in the DevOps movement and is often used in conjunction with cloud computing. Infrastructure as code is a method where developers and operation teams manage and provision IT infrastructure through code. Instead of manually configuring and managing servers, storage, and networks, they are defined in code files that can be versioned, tested, and audited. The code can be written using high-level languages such as YAML, JSON, or domain-specific languages like HashiCorp Configuration Language or HCL. For example, a developer might write a script that automatically sets up a server, installs necessary software, and deploys an application. This script can be run multiple times, creating identical environments each time, which is a property known as idempotence. The main goal behind infrastructure as code is the elimination of snowflake systems. A snowflake is a configuration or build that is different from any other. It lacks consistency and might introduce risks to our digital environment. Now, to fully understand infrastructure as code, you need to be familiar with idempotence. Idempotence is a fundamental concept in infrastructure as code. It refers to the ability of an operation to produce the same results no matter how many times it's executed. An idempotent script will set up an infrastructure that is identical every time it is run, regardless of the infrastructure's initial state. This is crucial for maintaining consistency and reliability across multiple environments. Infrastructure as code offers several significant benefits, including speed and efficiency, consistency and standardization, scalability, cost savings, and auditability and compliance. First, speed and efficiency. Infrastructure as code allows for the rapid provisioning and deprovisioning of resources, which can significantly speed up the development and deployment process. Second, consistency and standardization. By defining infrastructure in code, organizations can ensure that every environment is set up the same way, reducing inconsistencies and errors. Next, scalability. Infrastructure as code makes it easy to replicate infrastructure setups, which can be particularly useful when scaling up operations. Next, cost savings. By automating infrastructure management, organizations can reduce the time and resources spent on manual configuration and troubleshooting. Finally, auditability and compliance. Since the infrastructure is defined in the code, it can be versioned and audited, making it easier to track changes and maintain compliance. Despite its benefits, implementing infrastructure as code is not without its challenges. These challenges include its learning curve, the complexity, and security risks. First, the learning curve. Infrastructure as code requires a new set of skills and a shifted mindset. Teams need to learn how to write, test, and maintain infrastructure as code. Next, complexity. As infrastructure as code grows, it can become complex and difficult to manage. This can be mitigated with good practices like modularization and proper documentation. Finally, security risks. If not properly managed, infrastructure as code can introduce security risks. For example, sensitive data might be exposed in code files, or insecure configurations might be inadvertently introduced. So remember, infrastructure as code is a method of managing and provisioning IT infrastructure through machine-readable definition files. Infrastructure as code allows for rapid provisioning, consistency, scalability, cost savings, and auditability. Infrastructure as code also comes with challenges, including a steep learning curve, potential complexity, and security risks. By understanding and effectively implementing infrastructure as code, organizations can greatly enhance their IT operations, making them more efficient, reliable, and scalable.